Okay, so Monday, we didn't meet in class, but I'm not changing the schedule. So, here's the video from, I just posted the video from last semester. Seems like it was a pretty good video. Looks like it went pretty well. Did any of you actually watch the video? Was it a good video? It worked out okay? Yeah, I mean, like they do research on videos, like, what's the characteristic video that people will actually watch? And today it's like, it's got to be less than 6 minutes. And, this was like an hour and something. So I know most of you, if you watch it, you'll probably watch it on double time. That's okay. So, but today then we're going to pick up, so this is idea of writing macros from scratch. So we're starting with an existing workbook. So let's go ahead and get this one downloaded. Make sure that you, unblock it and then get it open, and we'll take a look. So while you're getting that up, let me kind of give you the background here, what we're going to try to accomplish. Oh, there's a sheet 2. What's in sheet 2? I don't think we need sheet 2. So when you're a professor, like most of what you see faculty do is just teach, but teaching is actually kind of a small part of my whole job. Main part of the job for most of your faculty is research, like doing original research and figuring out new things. And then they've got like service requirements too. And my major service requirement is I'm the academic scheduler for the Marriott School. So I'm ultimately the one who decides which class gets taught in which rooms, and have to figure out how to solve the problem when we've got 2 classes that want exactly the same room at the same time. Fortunately, all the faculty here are really great to work with, and it doesn't end up being too much of a problem. But one of the problems is that this is like the data, the way that we have to work with it. We get the data kind of from the university system. And I think this is data that I downloaded, looks like in 2017 or 2018 or something. And so, but this is really tough to kind of be able to look at it and tell, when do 2 classes conflict with each other? Like if we're going to try to look at this data and say, we want to know, we kind of want to make sure that we're scheduling these at times that students can take them. Like if there's like particular elective that we know lots of students want to take and it's only offered once, we want to make sure those 2 aren't offered at the same time and make the students have to choose between those. And so it's really difficult to look at the data here, but if we could do this a little more visually, that would be great. So our task today is to take this data here and then be able to make a visualization of it right over here. So what we'd like to do is we'd like to say, all right, this one starts at 12:30 to, that's really great data. That should be 1:45 p.m. I don't know what 13:45 p.m. is. 13:45 I get, or 1:45 p.m., but I think that's still going to work okay for us. So how would I mark this one as 12:30 to 1:45? So I would say that's this block right there. That's when that is. So what I want to do is put some kind of color on that to say, yeah, I want to be able to see kind of how these line up against each other. And then the fact that some of these are Monday, Wednesday, some are Tuesday, Thursday, some are every day, I might like to have like those, like depending on the schedule, to have them show up in a different color or something. I'd like to have that happen automatically. So, so the project, first of all, we got a project due tonight. So remember that. How many of you have already submitted the project? Oh, wow, that's great. As we get closer in this semester, when I ask like on the day it's due, there'll be fewer and fewer hands. Say, hey, professor, it's not due till midnight, so we haven't even started yet. So, that's good. And remember, that project is kind of the whole process of recording yourself doing something and then modifying it. And so today, what we're saying is, no, we're not recording anything. We're just going to write this thing from scratch. And so this will be kind of a satisfying experience to kind of go through and write code that will do this. We're kind of seeing the process of doing this from scratch. So maybe, there's already some code here going. And so anything else, any other administrative questions that you want to maybe address before we get into the instruction for today? So it's our first project that's due today. And remember, projects are different than homework. So it's probably just a good moment to review this really quickly. Homework, I'm allowing you to like totally sit down with someone else and figure out a single solution. As long as your fingers are typing it, that's great collaboration on homework. But that's different for projects. What's the restriction I'm expecting from you on projects? Are you allowed to talk to other students about your project? And hey, gosh, how should I go about doing this? Would that be okay to do? Yeah, that's all right to say, hey, how would you go about doing this? Well, I might start off by recording myself, maybe make a web query first and record myself editing it and whatever. But where do we draw the line for projects? What are you not allowed to do with projects? Share code, right? You're not allowed to show your code to anyone else or look at anyone else's code. You can talk pretty specifically about the algorithm, but in English, not in VBA. Okay. Well, let's go ahead then and take a look at this one. So I'm gonna go ahead and bring up the code. We've got a little bit of code in here. Ooh, not very much. Let's see, let me view my project explorer. Okay, yeah, so we've got one module and all I've got in here is a sub procedure that says make schedule. So I think I want to kind of think about how could I break this problem down into smaller pieces so it's not like so challenging. And I think a pretty straightforward way to break this problem down would be to say, listen, I've got something that has to happen over and over again. I've got to look at this row and highlight some cells over here and then do the same thing and the same thing and the same thing. And so rather than thinking of this as one problem to solve, let me think of it as, let me write a sub procedure that does one of these, and then we'll have another one that says, just make that happen over and over again. Really similar to how I've asked you to structure the project then that's due for tonight. So make schedule is going to be the one that does it all. So why don't we say schedule one class, or maybe just schedule one. So make another sub procedure here called schedule one, schedule one. Now we're gonna do something a little bit different here. So, for our last example where we had another sub procedure that was being called from one to the other, we would just call the one directly. But I'm gonna now introduce to you what we use these parentheses for right here. Now we've seen how to declare a variable, but it might be interesting for me to know which row I'm working on. So we just come here and start off by saying, I'm gonna declare a variable called row as a long integer. Now, the trouble is, when I'm scheduling one, this value row here, it's going to need to be different for each one, because the first time I call it, I would like to tell it, hey, schedule, schedule the class that's on row 2. Call it again, I want it to work on row 3. Again, I want it to work on row 4. And so we could do something where, like up here, we're changing which cell is active, and then down here, we're reading which cell is active to figure out which row to work on. But this is really what these parentheses are for. So instead of declaring this variable inside, or just here inside the module, I'm going to declare it inside these parentheses. It's the only thing I'm allowed to do inside these parentheses is declare one or more variables. Here I'm just declaring a variable. Because it's the only thing I can do inside the parentheses, I don't even need the keyword dim. I just, that's the only thing I can do is make a variable there. And so not only do I not need the keyword dim, I can't even put it there, but I am just declaring a variable. This is a special variable, a special kind of variable called a parameter. A parameter is just a variable that's going to get its value set when this procedure is called. And so you may remember that in the last example we did this in, we said call and then the name of the procedure. Now, this is expecting to have a value passed to it. And so, and in fact, we use call here just because it's kind of nice to see a little more English statement, what's actually happening here. But almost no one, I never ever see that word used. So that's just actually unnecessary. So if you just have the sub procedure on a row by itself without the word call, it's calling that sub procedure. And now I'm going to pass it a particular row. I'm going to pass it 8. Now, all I'm going to do down here for starts is I'm just going to print off whichever row was passed in. So debug.print row. So the trick is that when I run make schedule, it's going to say, hey, run schedule 1 and give the value 8 to its parameter. And so that's going to say, go run schedule 1. Schedule 1 is going to run. It's going to set the value to 8 here, and it's going to print out the value in that variable row. So this will print 8. Yeah, this is going to print 8. In fact, here's proof. I'm just going to run this, and it prints 8. Okay, so now, if I can just, now I'm saying, hey, we're going to pass in some row here to work on. Great. So we can just we can think about this as one row, and then we can think about making the loop happen later. In fact, maybe we'll make the loop happen first. So why don't we just do that as kind of a quick in-class example. We'll give you 4 minutes to make a loop around this call here that will call this once for every row that we have. So we're going to start, we don't have to start with row 1 because row 1 is just the headers. We'll start with row 2 and we want to go all the way to 55. But if we import more data and instead of having 55, we've got 85 rows, we want it to go for 85. So we don't want to hard code how many rows it's going to run. We want it to start at 2 and keep going as long as it has data. So let's take 5 minutes or 4 minutes and give that a go, a little in-class exercise. I will put up a timer and we'll do that. If you have a question, raise your hand and I'll come and take a look. I'm recording. Okay, so first of all, there's three kinds of loops that we covered in the video from Monday. There's the one that we were first introduced to, which is the do loop. There's one called the for loop, and there's one called the for each loop. Of those three, which one do you think is most suited to this? The truth is, you can use any one of those three loops to make this work and work well, but one is particularly suited to this task. Which of those three do you think it is? Take a guess. The fourth one? Oh, the for loop. For loop would work, but I think the do loop is probably better. The for loop lets us say, you know what, we're going to iterate for a specified number of times. We're going to start at a number, end at a number, and that's how many times we're going to go. And that would work with the rows. But the for loop is great when you say, look, going into this, I know exactly how many I have to do. What the do loop does is it says, you know what, I'm just going to do this until some condition happens. So I'm going to kind of keep doing this until I bump into a blank row. It's really designed to kind of think about, should I continue at the end of each iteration? And although we could, use the for loop for this, I think the do loop is probably a little bit better suited for us. Let's go ahead and give it a shot. So I'm just going to say do here and loop here. And so this now is an endless loop, right? I don't have any way out of this. So I'd like some way to be able to keep track. So let's do this. Let me declare a variable up here. Just call this one R. I want it to be different from row just so that we see it doesn't have to be named the same. So I'll dim R as a long integer. I'm going to give R an initial value, R equals 2. And now I'm going to pass R down instead of 8. So the first time I come through this, R equals 2. Do says, hey, this is the beginning of the loop. This is going to call schedule 1 and pass it down the value 2. So that value 2 will be received into this variable and it'll print 2. Now, I really better do something to change that. So after that runs, I'm going to increment R. So R equals R plus 1. And so now we'll get to the keyword loop. Loop says go back to the do. Now the value, at this point, the value of R would be 3. We'll call schedule 1. We'll pass it down to 3. It'll go print 3. And then R will go to 4, 5, 6, and 7. And it'll print all those numbers off. Now, if I were to run this now, it would run 1.04 million times. I haven't given it a way to stop the loop. It would run all the way till it got to the bottom, and then would try to go past the end. It would have an error, and that would cause the loop to stop. So the do loop is particularly susceptible to this. It's really easy to inadvertently put yourself into an endless loop here. So it's always a good idea to put this word in do events. Do events, it says to the interpreter, I mean, you got to think about this poor interpreter here has been in every copy of Excel that has shipped since 1995, and almost no one knows that it's there. And so every day, when Excel gets opened, the interpreter says, maybe today's the day my user is going to use me, and the worksheet gets used all day long and the interpreter doesn't get used at all. At the end of the day, Excel gets turned off and the interpreter says, maybe tomorrow. And so by the time we finally give this interpreter something to do, it is so excited to do. I mean, even something really boring like this, it's just so thrilled to do it. It's like, I'm going to do this. And if you try to stop me, I'm not going to pay attention to you trying to stop me because I finally have something to do. And what do events does is it says, okay, at this moment in the loop, just pause for the briefest of milliseconds and check to see if there's something else that we're trying to do. Like if I'm trying to interrupt this code, this will allow me to break into it. So if I inadvertently put myself into an endless loop, as I've done here, this will let me break out of it. So if it's running, and let's go ahead and run it. I'm out of habit. I'm going to save this. So it was a good habit to save anytime you're making a loop, because if you do put yourself into an endless loop, schedule 2, W23, and you can't, and you're not able to break out of it. You've just got to close Excel and start again. You've lost whatever you've done. So probably a good habit to be into, just to save anytime we're doing a new loop. And if I run this, yeah, there it goes. It's counting on its way to 1.04 million. It would probably, as fast as it's going, it might get there by the end of class. I'm not going to wait for it. So I can come here and press the pause button. And because the do events is there, it's saying, oh, yeah, you're trying to get my attention. It'll stop. Without that do events, there'd be no way for me to stop that code. By the way, I can start to run again here. Your keystroke to do that is control break. You may or may not have a control break on your keyboard, depending on who the manufacturer of your laptop is. But if you can get back to here, you can always hit the pause or the stop, and that'll break into it. So I need some way to get out. And so how am I going to get out? I'm going to put an until clause. Do until cells row number row. Oh, we haven't learned this. This is actually what we're going to be covering next Monday. So this is a way to refer to a particular cell by giving it a row and a column separately, instead of just like having it put together as a string. So row, column number 1, until that cell's value is equal to an empty string. And so now what it does is it says, okay, hey, we're starting a loop here, but let's check and make sure this condition is true. So because it's going to make sure this condition is false. So this is going to execute until this condition becomes true. So do until whatever cell we're looking at here is empty. So it's not going to be empty, on 2, it's not empty, 3, it's not empty. So it's going to continue to execute as R gets bigger. Eventually R will get to 56, and that will cause it to get out. So let's just go ahead and run this and see what we get. So yeah, so now it has executed at 36, 37, executed at 55. There's data on 55. It then, said go schedule 1 row. It passed at 55, or 1 row, or schedule 1, printed the 55. This now went to 56. We got to the loop, came up here, and it said do until that condition is true. And at this point, that's true, right? That is now true, and that's what gets us out of the loop. Okay, so how comfortable? Just show me how comfortable you are with what we just covered. See, that's it looks like mostly 5s. So what I'm and this is kind of normal. Like you're going to see code, and you're going to go at the beginning of this class. It's like, yeah, I totally understand that. I couldn't have come up with that on my own. And that's an okay place to be right here today. So we're still pretty new at this stuff. So we're getting you together some tools that you'll use to start piecing things together. Okay, so that looks pretty good. Let me do one more thing here. And I'm just going to come in here and say exit do. So I'm going to put this exit do in here. Oops, exit do. That's just going to say exit do just gets me out of the loop. So while I'm doing this debugging, I'd like to be able to run this and have it run just one time. I don't want to have to run the whole thing every time I'm just trying to make this thing work. So now it'll just run 1. And if I decide, what, I'd like to start on row 6, I can just change the 6 here and run it. That'll just now run row 6. And so that'll be pretty good now as I'm trying to figure out how to actually make this schedule 1 row. Okay. So let's think about this. Think about the algorithm. Any thoughts about what we should do? Control home. All right, because our task is to look at this row and be able to figure out, we got to highlight those cells. Any thoughts on how to tackle this? Or don't you have to go big picture? Maybe just what's one step that we should be thinking about doing? Yeah, go ahead. Oh, okay. So definitely we're going to have to do something with these time values. We know that this thing starts at 12:30 and ends at 1:45. So we're going to have to be doing something to look at those. And ultimately, we're going to have to look at these, and we're going to have to convert the information that we have here into a starting column and an ending column. Ooh. So any thoughts on how we might do that? Yeah, go ahead.
Take the difference divided by 15.
Okay, so first thing is we've got 15-minute intervals, because the way we've got this sheet structured is that it takes 4 columns to equal an hour. So I think that's a really great place to start. So if we could look at our start time, and let's just figure out how many columns we're going to need, or maybe what our start column is going to be. So in fact, on the way to figuring out what the start column is, we need to know how many hours there are here, and we're going to have to multiply that by 4, because each hour has 4 hours, or each hour has 4 columns. Yeah, have you ever been in a class where it felt like that? Each hour was actually 4 hours. Yeah, hopefully that's not this class, but and then we'll have to do something with the minutes too. So let's start by extracting out and kind of pulling out what's the start hour and what's the start minute from this. And so this is in column I. Interesting. Okay, so maybe I'll start by saying, instead of printing that row, let me print cells, row number row, column number I. Now, I is the 9th letter of the alphabet. So I can do that. I want to print the value of that. And so if I run my code now, it's printing 8 a.m. Oh, that's because I'm on row 6. I want to start on row 2. So let me go back and modify my code to start on row 2. And I'll run my code again. And yeah, so now that's printing 12:30. Okay, so now I've got that. Now I just want to think about, how am I going to extract out the hour from that time? Any thoughts? I don't know why you would know this, because I haven't taught you this, but how could we convert that 12:30p into just a 12? Well, actually, let's do one more other thing first. Let me back up. By the way, for this cells, for the column, if you want to, you can actually put in, what was it, H-I-J? You can put in a string character. So if you want to think of it as like column I, you can do that. Let's look at column J for now, because I think it might be a little more interesting to look at our ending time. And so, yes, our ending time now is 13:40 p.m. Let me just go ahead and adjust that to be 1:45 p.m. I think where we're headed, that will work the same either way, but I think for this example, it's more important for us to think about that as a 24-hour clock rather than a 12-hour clock. So what I really want to get off of this is, I want to get 13. Hour number 13. So any thoughts on how to do it? Maybe from some other language that you might know.
Can you just wrap the cell value in hour?
Yeah, so that's exactly right. There's a function in VBA called hour, right? So I could just come up here and just kind of test it. I could say hour, H-O-U-R, and give it the string that I'm working on, and that will extract off, which hour there is from that time. It's going to look at this and say, can I understand this as a time? And if so, it goes, yeah, it's a kind of a standard time format. I can figure out what hour we're after. If it's not a standard time format, like X or something in there, it's going to be like, I don't know what you're talking about. But if it looks at what you give it and says, yeah, I can understand it as a time, that'll work okay. So even in my poor worksheet here, that even if it says 13:45 p.m., it'll still understand that well enough to say, you must be talking about hour 13. Okay, so let's go ahead and do this. Let me dim a variable called the start hour as an integer. I'm gonna do this as a byte. What's a byte? The data type byte can handle what kind of data? Numbers, only integers, starting, and the range is, anyone remember the range? Yeah, 0 to 55. You're already getting ready for the midterm. You'll want to know that by the midterm, by the way, but that's right. So that's going to be just fine for my start hour. And then let's go ahead and just set its value to here. So I'm going to say my start hour is equal to, and my start column is in I. So let me go back to I on this. And then I'll come down here and I'll kind of print things off as I'm working on them. So debug.print start hour. And so now when I run that, it should just give me, my start hours is 12, so it should give me 12. Or it should give me a type mismatch, start hour. Oh, that's because I never actually told it to take the hour out. Now what was that type mismatch? Let's look at this error. So this type mismatch says, hey, you are trying to put one type of data into a variable that's meant to take a different kind of data. This is actually, like a string of, what, 1230p. And it's saying it's a mismatch of the type. The data type is the wrong type here. What did I forget to do? Yeah, I forgot to try to extract the hour off this. So hour of that. Okay, so now when I run that, it's going to give me 12. Excellent. Let's go ahead and do the same thing for a start minute. We've got start hour, start min. Start min is equal to the minute of that same thing. Question? Start min. Start min as fine. Thank you. Was that it? I guess that was it. So I'll go ahead and print that one off as well, just so I can make sure that it's coming along right. Yeah, so I got 12 and 30 separated out. Okay, so now I'm going to want now that I've got those two, I think I'm equipped to start thinking about what my starting column is. So I'll make start call 255 columns. I don't think I'm going to get past, so I think byte will work fine for my start column as well. If I was worried that I might have to go wider than that, my next one up is integer. That would be fine as well. Whew. Okay, so thoughts on how we're going to calculate now the starting column. Okay, go ahead.
I think you would do an hour minus 8, then multiply that by 4.
Okay, so let's see why you're saying hour minus 8. Oh, because is the 8 because we're starting at 8 a.m.?
Yeah, we'll start at 8 a.m. Use that as like the base column right there.
Oh, okay. Okay, so yeah, okay, so I like where you're headed with this. Okay, so start call is going to be hour. Now we're doing columns, so how do we convert hours to columns? So we take hour times 4. And since we're starting at 8 o'clock, let's subtract 8. Let's subtract 8 off of that. Not hour. This is called start hour. So let me go ahead now and put my start column here as well. Okay, so that's telling me that it's column number 40. Now, if I look over here, this is, I actually want this to start. Now, we've got some other offset that has to happen here because we've got like all these others, like that's, that right, yeah. So we need to do some kind of adjustment to kind of get us over here to column O. I don't know what letter of the alphabet column O is, so I just made that my active cell. I'm just going to print off active cell dot column. ACTIVE active column. So that's the 15th column is where we're going to be starting. Could have also got there by singing the ABC song and counting on my fingers. That would have got me there as well. This way, I think it's a little more impressive. Okay, so so when I've calculated my start column this way, I need to adjust that from 40 down to 15 to where I actually want it to start. So if I take 40 and subtract 25 off of that, whoops. Minus 25. I'm not entirely sure that's even headed down the right direction here. But let's go ahead and give that a shot and see what happens. Okay, so we've got 15 there. Oh, but it's not quite right because I don't want to start at 8 in this case. Where do I actually want to start for this one? I want to start here. So I shouldn't be looking at 15 as my target. I should be looking at whatever that one is. Shouldn't have deleted that. Back to cell dot column. So 33. So when I've calculated that 40 there, I want to move it to 33. So is it minus 17? Yeah, in fact, I think I can just adjust that right into here. Let me minus the 17 here. What does that one do for us? So that's getting me 31. I'm close. What was I after? Oh, this is 12:30. Starts at 12:30. Starts at 12:30. Ah, sorry. The 12, I haven't got the 30 anticipated yet. The 12 should be getting us to right here, which is the thing where we are. So that's going to produce 31. That's the 12. We now need to offset that by the minutes. So how do I get the minutes? So that's gotten me to the column 31 here. I need to adjust over 2 minutes. So what am I going to do with the minutes there? I'm going to add something on. Add minutes divided by 13, or divided by 15. Excellent. So I'm going to add on to that my start minute divided by 15. And hopefully that's going to give us column number 33. Whew. Okay. Well, I think that works. Let's just plug it onto a different one. Let's plug it onto number 6. Row number 6 was starting at 8 o'clock, so that one should give us column 40. So we come here, 6, or column, not column 40, column 15, right? That's what we figured out O was column 15. So that looks pretty good. So when we're hour is 8, minute is 0, column 15 is the one that we should be calculating. Okay, I think that does a pretty good job of getting our starting, we've calculated our starting column. All right, another in-class example. Be kind of an example in kind of modifying existing code, but also now calculate our ending minute, our ending column. So it should be really, really similar to this. So just do that. Let's see how far we can get in 4 minutes. So we've got this code here. Copy what you need to be able to also calculate the ending column. We've got the start column and the end column. And again, if you have questions, raise your hand and let me come help you think through it. All right, let's go ahead then and take a look. So I'm guessing that if you finished it, let me see your hands. Probably, I mean, only a few of you. Oh, more than I would have expected. For those of you who didn't finish it, show me your confidence on, like, if you had more time, you'd be able to get there. Looks like those of you who are turning out to the polls today are feeling pretty confident about it. Okay, so yeah, I'll just go ahead and do this pretty quickly. Can you hear me better now? Okay, so I'm just gonna copy this whole thing. And maybe except for the debug.print. Now, as it turns out, we are allowed to put these variable declarations anywhere in the code, as long as they're before we actually use the variables. But the way VBA works is when this procedure goes to run, the VBA interpreter looks at this code and it figures out all the memory it's going to need. And it allocates that memory before it starts running any of the code. So even though these dim statements can be interleaved, logically, they all happen up here before. So I'm just, and it's like a stylistic thing. Some people like to put the declarations at the top because that's really where they happen. Other people like to declare the variables close to where they're used. Either way is fine. It's really not, it's just kind of a preference thing. And so I'm just going to change my start to end on all of these variables. And then we'll have, I guess I'll do the end first. I don't really matter which one I do first. So instead of I now, I'm going over to J. And this will be pulling my end hour off of that cell. And column will be my end hour and my end minute. Let me go here and go ahead here and put on my end call now and see what it does for me. I don't think I'm quite there yet, but let's see what that does. So what I'm really shooting for, my start column here is 33. And the end column that I'm after is 37. So let's see what I've got. Let's see what I've got so far here. End cold. Boy, if you could write a program that would end the common cold, we'd all retire. We could all like retire early. Oh, I'm on number 8. Let me come back to my first record. So I'm starting on 33 and I'm ending on 38. And I think the reason here is that if I was to think of this kind of as a continuum, like I'm starting on, like when I plug in a cell, it's like taking up 15 minutes. It's like, it starts here, but my ending one is ending here. So it's always my algorithm is gonna give me one extra column. So I think I'm just gonna subtract 1 off of it. So for my end column, I'll do that calculation. And I'll just minus 1 here, minus 1 here. Oh, I could do that minus 1 right over here and just subtract 16 off of that one. Subtract 18 off of that one, thank you. And right, subtract 1 more off of that. And that would then give me the same thing. I guess I have to do it either way. Okay, so now I think we've got the information that we need. We know the row we're working on because that gets passed in. We now know the start column and we know the end column. We just have to figure out how to use that information to be able to color a cell. So let's first get that to actually give me the cell reference, and then we'll see how to actually change the color of it. Okay, so this is something that we're going to go into more detail on when we get together on Monday. But you're familiar with the range method because we recorded ourselves with this. ADDRESS. So if I said range A1, give me the address, it's going to, just find that object and then give me back that property. You're also familiar with cells, and if we were starting on, if our row was row 2 and our column was 31 or 33, I guess is where this starts. We ask for the address of that. Cells, ADRESS. That's AG2. That looks like that's right. But we can actually combine these because this range one is really, really pretty neat. Here's one thing I could do. I could come in here and I could say A1, but then put a comma in here and say B17. And that is going to give me a range that starts in A1 and ends in B17, right? It gives me like a reference to that whole range. But not only that, I can use not just a string, but I could use another reference to a range, right? This gives me a particular cell. I could plug that in as like the ending, as the second argument. And that now is going to calculate that range. And so by plugging that in here twice, and ultimately what I'm after is like that row, that column, and this was 35. What did it go to? 35, 36, 37, 38. Oh, no, it's 33, 34, 35, 36, 37. So we're after 37. And that's going to give me, let me go ahead and select it instead of just printing it. Yeah, that's selecting just the range that I'm after. And so now I've converted all the variableness here in this expression just down to numbers, and they're numbers that I already have calculated. So if I was to take that expression, do this as a separate debug.print statement. I'm going to print the address of that. Now, what am I going to change? And so right now I have the row hard coded. What do I need to change to get this to be the proper row? What do I put here? Yeah, right. We've got that variable row that's getting passed in. That's telling me which row I'm working on. And so wherever I have that 2, I'm going to make that row. And then this one is my start column. And this one is my end column. So now that should give me that same address, AG2 to AK2. Go ahead and run this. And so it's still printing off my other debugging information here. And I've now identified the range. So now I've got a reference to the range that I'm trying to color. How am I going to figure out how to change the background color? Record myself doing it. This is where experienced programmers will often forget this because they are so used to answering that question by saying, just Google how to do that, that they'll spend a long time looking on Google before they realize how easy it would be to have Excel generate the code for me. So no problem. I've already got my rows selected and I've got that range. I'll just record myself doing it. So this will be pretty simple code. You can record along if you want, or just watch, that's fine. So developer, record macro. Macro one's a great name. I'm just going after the code for it. And so I'm just going to come here and change it to a different color. How could I do that? Come over here to, let's do this. I don't remember how to do this. I'm going to come to format cells. Over here, I will choose fill. I'm going to do more colors. All these colors right here, these are like part of a theme. So if I change the theme, these colors will change. I just want to change it to a particular color. I'm just going to choose more colors here and choose that color. That's a great color. Say, okay, I've changed that color. And now I will stop recording. And let's go take a look at what that recorded. Now, every time I've opened this workbook and I start recording again, it'll make a new module just for the recorded macros. So I've been working in module 1 and it's recorded in module 2. Still didn't do what I was after. Oh yeah, it did right here. This is the line I'm after. So again, we've got the width here and I've changed multiple things. So width, whatever is selected, and then that selection has a property called interior. So I'm making several changes about the interior of that cell. One of them is the color. So now I know it's .interior.color, and there is the value that I'm after. So, oops, come back to module 1. And then instead of printing this, I'm going to refer to it. And I'm going to say, I've got that range now, dot interior, dot color equals that number. So I'm going to just go ahead and clear that out. We'll run this and see if it does what I'm after. Yeah, colored that right where it should be. It's made my life a little bit worse here because I've got this macro one, it's alphabetically smaller. So when I just run my code, it says, you want to run macro one? I really don't want to, and I'm done with this. So I'm just going to delete this, and maybe I'll just go ahead and remove this module. So remove module 2. When you remove a module, you probably think this means, are you sure? But it's not what it's saying at all. It's saying, do you want to export this before you remove it? Like you can save this module as a text file that you can import somewhere else. I don't want to. So I'm going to say no here. That will delete it. So great. Let me just go try a couple more of these. So let me try, go back and try number 6, that one that's supposed to start at 8 a.m. Run this. Yeah, did it do it right? This is from 8 to 9:15, 8 to 9:15. Yeah, I like it. Should we cut the loop loose and let the loop run? I think so. So what am I going to do? I'm going to come here and just get rid of my exit do. I'll just comment that out because I may want to put it back on depending on what I'm trying to do here. And I'll go ahead and run that. And now it looks like it's done a pretty good job of showing me, like my last class. These classes are ending kind of late. What is this? 4:00 p.m. So that's looks like it's 4:45. Yeah, 4:50. So we're doing a little rounding here, but yeah, that's kind of showing me where it goes. Looks pretty good. Okay, questions on what we've done here so far? Yes.
Can you scroll back up?
So now I think what I'd like to do is make the color go a little bit different if it's a different day of the week. So to do that, did you see enough for here? Let me go ahead and make another variable here just called color. As, let's see, there's like 16 million colors. So integer is not big enough. I better do long integer. As long. Now, as it turns out, there's more than 16 million different colors, and each color just has a different number. How could you learn what all those numbers are? I don't know. That's a lot to memorize, 16 million. The midterm is not that bad. You don't have to memorize 16 million things. And so there's a couple of ways for us to get at these different colors. So one, let's do this. Let me just come in here and instead of having this hard coded here, I'll put my variable here, color. And then maybe just before I do that, I'm going to set the value of color. So if you were to think of, what color would be the devil's color? Like if you're thinking what color just says devil to you, what would it be? See, red is pretty good, but it's also like the color for Valentine's Day and such. So it's probably dark red, probably a dark red. This is like the one that you could probably memorize, because if I was to make that color 666 and run this, it would go dark red. I don't know why but that's what it is. You could probably also remember black because black is the number 0. But other than that, they're just in there. But there's another thing that we could do. So let's do this. Let's say if, which class should be the devil's class? The ones that meet every day of the week. So let's do that. Let's say if column H is this expression, Monday, Tuesday, Wednesday, Thursday, Friday, then that's going to be this color. So again, we've got the if statement coming up, but we'll just do a simple version of it here. If, and then cells. We're looking in column, was it H? Yeah, H. If that value is equal to Monday, Wednesday, Friday, then color is 666. Let's just set color to be black otherwise. So 0 is black. And then we're going to say, listen, if this is a class that meets every day of the week, we'll change it to different colors. So now when we run this, we should get some that are red and some that are black. We'd like to give it a little more, a little more color as well. So I'll run that. And so does this look right? Yeah, these are all the ones that are Monday through Friday. Yeah. And then these other ones are here. Why is this one green?
Your code starts on this.
Oh, thank you. So yeah, I probably should set this back to 2 so we get all those. Okay. Now there's a couple of different ways for us to actually get to these colors. Fortunately, you don't have to just go to the color number. So here's another one. So let's say if it's a Monday, Wednesday class, I can compose a color by the amount of red, blue, and green that I'm using to do it. There's a function called RGB. RGB gives me, I tell it an amount of red, blue, and green that I want. So if I say 0 red, the most blue possible, 255. 255 is it goes 0 from between 0 and 255, and 0 RGB and 0 green. And that will give me the number for solid blue. So I can either type that in now, or I could just use this to go in there. So if it's that, we want this to be RGB, that particular one. So we'll run that. Monday, Wednesday. Do we have Monday, Wednesday? Oh, I didn't change. I changed the wrong thing. This is supposed to be H. So column MW is a real column. I don't know where it is. But this is supposed to be Monday, Wednesday. So now there's my Monday, Wednesday classes. So my black ones are the ones I still haven't anticipated yet. This one is, this is Friday only. But it turns out there's also some colors that are predefined. So let's look for ones that are just Friday. Like there's some constants that are defined here. So we talked about variables kind of in detail, like on our second day of class. Constant, we might have mentioned, but briefly, is just a variable that's value doesn't change. And you can create a constant and give it a value. You can set the value once, but there are a bunch of constants that are built in. Here's one. So VB yellow. So VB yellow is that number right there. And so that would be another thing that I could put here is that constant that evaluates that same number. So now yellow is not a very good one because it's not that different from white. It's a little hard to see, but pretty good. Who else are we missing? Who's black still? There's a Tuesday, Thursday class. Can make that one kind of green. And you could kind of find out what these other ones are. Let's see. That was, I did that for Friday as well. This needs to be Tuesday, Thursday. It's Friday, it's yellow. If it's Tuesday, Thursday, it should be green. Oh, Thursdays are. There we go. Okay. So far, so good. I'm not sure what else we want to do. And I'm also not sure how I did this in like 12 minutes faster than I did it last semester. I don't think I forgot to do anything. That's what I wanted to show you today. We can take a look at modifying this. If we'll take requests from the audience. Anything else you want to do here? And everyone's going, don't anyone say anything. He's about to let us out early. Don't say anything. We're about to get out early. All right. Well, take these extra 12 minutes and finish off that project or go watch the video from Monday. Thanks for coming. Class dismissed.